So the first panel session it's called AI and Image Authenticity, and we have some great people lined up for that. So Leonard Rosenthol, the lead author of the C2PA spec, and also lead of PDF, basically in the world, and PDF architect for Adobe, and has been working at Adobe for many years. I actually have a whole bio that I can read. So joined Adobe for the first time in 1996, and has been involved, I believe, on and off since then. And then we've also got Dennis Walker from Camera Bits, makers of Photo Mechanic, Neal Krawetz, I think you pronounce it, of FotoForensics, and Bofu Chen of Numbers Protocol. So I look forward to hearing everyone. So Leonard, would you like to start off? I'm going to give everyone 5 minutes to speak. Otherwise, we won't have enough time for the questions. So please do get going. Great.
Thank you very much. And hello to everyone from Tokyo, where more standards are happening. So I wanted to just take those couple of minutes this morning and introduce you to content credentials, which is the standard produced by the Coalition for Content Provenance and Authenticity, the C2PA that you've heard about already this morning. I want to start by saying, as we do within our name, it's all around provenance. So our focus of the organization and our belief around what is important for content is that it is important to understand its provenance, the beginning of its existence, its origin, and its life throughout its existence. So we don't want to just detect whether or not something was generated by AI or not. We don't want to just detect if potentially edits were made. We want to document all that information, because editing, manipulation are all things that people do on a daily basis with their content. And they should be able to continue to do that and not have to worry that some tool is going to come along and maybe think that that was a bad thing. So instead, we want to document the who, the what, the where, the when, the how, and the why of the life of a given asset. And as mentioned, this content credential standard from the C2PA does that. And it does that, as was mentioned before, by basically allowing you to sign an image, an audio file, a video in the same way that you have been signing PDF files for almost 25 years now. In that you take the information about the asset, the data, its metadata, including the IPTC data that you've added. You also can add additional information about, for example, your identity, trusted time, and you bundle all that together into this thing we call a C2PA manifest or a content credential, and it all gets packaged together with the asset and carries along with it. Again, just as you've been doing with IPTC metadata, you can think of this as a more secure, tamper-evident package of metadata. And that information is not just a linear understanding of the metadata, of the history and provenance of that asset, but as assets are combined together. For example, you place one photo or a series of photos onto a new canvas in Photoshop, or you use something like a generative fill feature to modify your photograph to add a little AI fanciness to it, then your graph, it becomes more of a graph and a chart, because now each one of those things represents an ingredient in the history and provenance. So C2PA has been operating since 2020. We have many different members, almost 100 at this point, and you can see various logos of folks, not only technical companies, but we also have human rights organizations like Witness. We have publishers and publishing organizations, and we have established liaisons, obviously with the IPTC, but also with well-known standard organizations such as the ISO and ETSI in the European Union. As mentioned, everything we do in C2PA is based on a well-understood trust model. It's the same model of trust that has been used, as I mentioned, with PDF for over 25 years and the web. So we are all familiar with that little lock icon in our browser. You can think of this as establishing a similar lock icon to your assets, that you want to be able to see some sort of graphical representation similar to the blue bar in PDF viewers or the lock in browsers that let people know when they consume your asset, hey, there is provenance here, and you can go look at it and find out more about this asset. And that, as you heard, that cryptographic foundation is not only based on those certificates, but also on those trust lists. And so the C2PA has a trust list. We're actually in the process of continuing to establish it. And the rules that we're establishing are also going to help guide the IPTC and its new trust list and those of others. We also have established rules for what's called hardware attestation. So this enables hardware devices such as cameras that incorporate C2PA natively to also declare that they are doing it in a trusted environment. But as you'll hear a little bit later, and is well known, metadata can be stripped. And that includes our content credentials. We're well aware of that. We've known that since the beginning of the process. And so one of the things that we are actively working on now is taking those content credentials and making them more durable. So we are establishing a series of standards that incorporate a three-legged approach, to a stool, if you will, that enables not only the embedding of that provenance, but the ability to have references to that provenance from invisible watermarks, and also what are called fingerprinting. And so the combination of these three components will enable that content, that provenance, to be located, even if it has become stripped. So you can see, for example, here is a browser plugin that can be used to locate that when it has been removed. There are 3 such browser plugins in existence, and more importantly, we are in conversations with the W3C, which is the standards body responsible for building the open web, to actually see this type of technology integrated directly into web browsers and your web platform. Here we want to talk about generative AI. That's part of this session. And so the indication that an asset has been produced through generative AI using those digital source types that were mentioned earlier is key to our credentials. So you can identify created by, modified by, composited with, all of those digital source types, again, expressible in C2PA. And you can see here on the right the example of someone taking a photograph of a computer monitor containing an image and being able to see that that photograph actually traces all the way back to the original asset using things such as fingerprinting and watermarking, part of the durable content credentials. So this is all part of the ecosystem that we are working to establish. You also heard about the new training and data mining work that is now part of IPTC. We've also been working on the same thing, and we have a similar assertion, that's the data structure in C2PA, for describing something with a similar vocabulary. We were all working together on defining these vocabularies and these rules. And they all trace back to work being done by the W3C as well. So again, a lot of alignment here between C2PA and IPTC, and a long history of that. And we look forward to continued work. I've been talking about this
We
already.
need to wrap it up, Leonard, so
Yep.
just be really
Yep,
quick,
that's
please.
fine. I'm just wrapping up, pretty much last slide. As I mentioned, embeddable in lots of formats and also referenceable, and you'll hear more about that from my fellow speakers. So thank you all very much for your time.
Great. Thank you very much, Leonard.
Thank you.
So now we move on to the implementer's point of view. So we get to hear Dennis from Cambrobits, Photomechanic, on what it takes to actually make this stuff work in a real image editing tool.
Great. Yeah. So let me try to share just this one. This one screen here. Okay. Yeah. So anyway, my name is Dennis Walker, and I'm president and founder of Krawetz since 1996. We make a software called PhotoMechanic, and that's used by photo editors to edit metadata and manage photos. So today I want to talk about recently announced technology for preserving metadata provenance. You might see some weird words in here about torch and flames, but could get explained here in the next slide. So yesterday we announced our technology for preserving C2PA provenance. And in the press release, I used an analogy of an Olympic flame. So think of a digital signature as an Olympic flame, and the camera ignites the flame, and the photo is the torch. So many times, PhotoMechanic is used as the first torch runner, and the torch is passed to other runners using PhotoMechanic. So we have a huge responsibility to keep that digital flame alive. So to help explain the challenge, I wanted to kind of go over some of the components of what a JPEG torch looks like. So there's two parts to a JPEG. There's the metadata and the image data. So the metadata contains editable metadata such as XMP, EXIF, IPTC, etc. And the camera creates C2PA camera creates a digital signature, and that's kind of like the digital flame. And the signature contains cryptographic hash assertions about the contents of the JPEG in order to detect modifications. Unfortunately, PhotoMechanic is all about making metadata edits, and a lot of them. So even though we're only modifying the metadata, the digital signature will still become broken because it only takes a single bit to change the cryptographic hash. So the challenge is, how do we allow multiple metadata edits without extinguishing the flame? So our solution to protect the digital signature and the metadata provenance is to create a provenance locker. This data structure contains all the metadata of the original photo. The provenance locker is then inserted back into the photo, and it replaces the digital signature. This allows PhotoMechanic or other metadata-only editors, such as EXIF tool, to safely edit the metadata because the signature is protected. And so the torch is easily passed on for further metadata editing. Once the metadata is finalized, it's time to pass the torch on to the next C2PA application by adding another flame. So this is where it gets a little tricky. So those of you who have been paid close attention to the provenance locker will recognize that when we combine that with the image data, we can extract, or more precisely, recreate the original signed photo. This extracted original is then used as a C2PA ingredient to carry on the digital signature provenance. Also, PhotoMechanic can compare the metadata between the modified JPEG and the original and make C2PA assertions that are included in the new C2PA signature that is added to the saved JPEG. So the new JPEG now has two flames, and the torch can be passed on to the next C2PA compliant workflow software. So in summary, PhotoMechanic can protect the provenance of signed photos by using the provenance locker. The metadata of protected photos can be edited repeatedly. After the metadata is edited, photos can be signed and passed on to other C2PA compliant software. And this provides for an efficient and authentic metadata editing workflow for C2PA photos. So therefore, we feel there is a clear path for news agencies to publish authentic photos from capture. And that concludes my presentation. Thank you.
Thank you, Dennis. That was very good.
Sorry, thank you very much, Dennis. You managed to come in under your 5 minutes time, so it's good we've got up a little bit now. So next up we have Neal from FotoForensics, the Hacker Factor blog. So I'll just read a little bit from the bio while Neal shares his screen. Neal is a specialist. He specializes in unconventional aspects of computer forensics. He's a recognized expert in computer security, networking, anti-anonymity technologies, file format forensics, and media analysis. So, okay, you're ready to go. So please get started.
And
Okay, can you see my
and
screen?
a pirate.
We can.
Okay. David Ricks asked me to be on this panel and to talk about authenticity. There we go. From the attacker's perspective. A little about me. I'm Neal Krawetz. My company is Hacker Factor, and I develop computer forensic software. I also run a variety of online forensic-oriented services. It's from these public services that I've gained an understanding of how people conduct online fraud. And when I talk about online fraud, people usually think about news outlets and digital alterations or fake news. But the problem is so much bigger than that. There's insurance fraud, banking fraud, fake injury claims, proof of life, proof of death, because, you know, if you're going to pay the hitman, you want to make sure he actually did the hit. There's propaganda, political influence, media, medical reports, scientific research, courtroom evidence, and much more. And it's not just the different industries. There are also different techniques: simple fakes, advanced fakes, deep fakes, altered images, staged photos, misrepresented pictures, and the list goes on. Since we're talking about C2PA, I'm going to evaluate it using the same three-legged approach used by C2PA that Leonard just mentioned. That's provenance, watermarking, and fingerprinting. Provenance focuses on the content and metadata that helps identify how a file was created and handled. All of that information is stored in the file. That means an attacker has direct access to the data. The attacker can easily alter, remove, replace, or re-encode the information in order to create a viable forgery. MIT Technology Review described this attack method as the shortcomings of the C2PA protocol and noted that it would not stem the harm of machine-generated misinformation. The second leg is watermarking. There are two different watermarking techniques: visible and invisible. Invisible requires special technologies to detect and decode the watermark. Companies like DigiCert specialize in invisible watermarks, and Stable Diffusion began adding invisible watermarks to some of their AI-generated images. Visible watermarks are basically overlays on the image, like the Getty Images watermark or the LiveLeak logo. The catch is, it doesn't matter if the watermark is visible or invisible. The watermarking method must be disclosed. Otherwise, investigators can't see it or validate it. But if it's disclosed, then attackers know the method. They can easily erase the watermark or add a fake watermark for false attribution. This is why IEEE Spectrum wrote that Meta's AI watermarking plan, which is based on C2PA, is flimsy at best. The third leg is fingerprinting. That includes visually similar picture search engines, as well as the mapping of complex file formats and camera artifacts back to the generating device or application. The problem with fingerprinting was demonstrated by the Russian car company AutoVAZ. They developed a sophisticated forgery method that replicates fingerprints onto altered files, resulting in forgeries that look original. And they have been doing this for over a decade. We've reached the point where Hackaday posted an article on forging fingerprints. They called it "Fooling Adobe's Cryptographically Signed Metadata," referring to C2PA. The root of this problem is trust. Typically, we trust the content and the metadata. We use tools, excuse me. We use tools and techniques to help identify alterations and validate any assumptions based on trust. C2PA adds a signature around the content and metadata. The thing to remember is that a strong cryptographic signature around untrusted data does not make the data more trustworthy. On top of this, C2PA introduces more areas of trust. Yeah, lots of new things to trust. Everywhere you see the words assume, trust, honesty, and not required is a vulnerable foothold for an attacker to exploit. To demonstrate how weak this model is based on trust, I'm going to show you one way to create an authenticated C2PA forgery in under 1 minute. So let me switch screens. This screen, share, window. Where did my screen go? Hold on, my screen vanished. This one. Share. Window. This one. So I went to Bing Image Creator, and I had to generate an AI generated picture this morning. And so here's the picture I chose, and I simply saved it as a picture called Gorilla. And if I go to Content Credentials, I can load up the Gorilla picture. And we can see that it is dated today because I made it this morning. And it's signed by Microsoft and everything's legit. Now I'm going to take my Gorilla picture. I'm going to copy it to Gorilla Edit. I'm going to hex edit the Gorilla Edit picture. And I'm going to search for that date. Today is 2024-05-07. There's the timestamp. And I'm just going to backdate it to March 11th and save that. And now I'm going to come over here and select my file. And here's my edited Gorilla. And we can see that's now dated March 11th. And again, there's no sign of tampering. I can even take another picture that someone else did. And this one, if you notice, I changed the date to October 2024, which hasn't even happened yet, but it was issued by Adobe and all the signatures are valid. So now I'm going to switch back to my slides. Share my slides.
I'll give you 1 more minute, Neal.
Sounds good.
I gave Leonard 7 minutes, so you can have 7 minutes as well.
No problem. There are other solutions besides C2PA, but most were not designed with the attacker in mind, leaving large exploitable vulnerabilities. The big takeaway is that authentication, provenance, and validation are hard problems with no easy solution. The other thing to remember is that attackers are not stupid. Trust and honesty are easy targets, and vulnerabilities will be exploited. And with that, I'm Neal Krawetz, and I'll turn this discussion back over to the panel.
Thank you very much, Neal.
Thank you, Neal.
And lots to discuss in the Q&A. So before the Q&A, we have Bofu Chen from Numbers Protocols. So please feel free to share your screen. Great. And go ahead and get started. Thanks.
Okay. Hi, everyone. I'm Bofu Chen from Numbers Protocol, founder and CTO. And before founding Numbers, I was a software developer working on open source project more than 20 years. My co-founder and I both believe in importance of open source standards in the future with AI. So we founded Numbers Protocol, an open source decentralized network aiming to ensure the provenance of digital media. A short introduction about Numbers Protocol. We use blockchain technology to index digital media content and make sure the content and its metadata are traceable and verifiable. Before going further, you might have a question. Why is blockchain needed? There are already some media metadata standards such as IPTC and C2PA, and they are all working well. However, blockchain does provide additional advantages, making sure the content history records are immutable, transparent, and can be connected to the broader Web3 ecosystem. Numbers Protocol builds a provenance infrastructure compliant with IPTC and C2PA. We built an SDK to help developers quickly adapt the provenance standards. We have a capture cam, which you can easily download from the App Store or Google Play. It's a mobile tool that can help users take photos with integrity assured. And the capture dashboard also allowed content owners to easily manage content and its metadata. You can visit our website for more details at numbersprotocol.io or scan the QR code here. So here I want to share some of our use cases include the Reuters 2020, the US post-election archive, the Ukraine and Children Drawing Archive collected by the Mama War Museum, and the War Crime Evidence Archive, and the Emmy-nominated project by Rolling Stone. The Archive of Taiwan Sunflower Protest Event, and Global Election Archive. And the capture of the award ceremony, working with Songwriters Association in North America. All use cases use the SDK or the dashboard and the CAN tools we provide to create the blockchain provenance and history records of the content. So provenance metadata will not be useful unless it can be verified. So I will introduce two verification pipelines, one for content with C2PA and another for content without C2PA. So for content with C2PA, user can upload content with C2PA to the C2PA verified site. The unique content ID, also called NID, will be shown at the top. This can be used to search blockchain networks and find on-chain provenance. Once the NID is obtained, you can use the asset profile service we provide. It's a visual service which is very similar to the Etherscan, the Explorer, so that you can review the content ID, on-chain provenance, and the on-chain history. If you are interested in more about the metadata details preserved in one blockchain transaction, you can also click the links and open it. In this case, this is the content collected by the Mama War Museum, and you can see the basic information and the extra metadata customized for the project. The default on-chain fields have their corresponding partners in either IPTC or C2PA and can be easily converted by tools. Another verification pipeline is for content without C2PA. For example, I can take a screenshot of the photo and share the screenshot on social media. In this case, there will be no C2PA. For content with no C2PA, user can use the numbers verified site, upload the content, and let the AI engine to find the match. Once the match content is found, we will know its NID, the unique content ID. So the next steps are the same. This ID can be used to search on blockchain networks and find the immutable content provenance and history. As mentioned previously, the advantage of using blockchain is not only to create immutable records, but also to leverage the open source community of Web3. In the verification pipelines I just introduced, all the histories and provenance are attached to the content using the ERC 7053 standard. This ERC allows you to write and trace multiple records on the same over different blockchain networks. It's very useful if one, you have multiple records for the same content, or two, you want to write records on different blockchain networks, like the Ukraine War Crime Evidence Project does it in order to ensure the accessibility of the evidence for 30 years after. Or three, you are checking the relationship between content.
Okay,
The idea of 7053 is simple. Let's say you have a photo, the original content file, and its provenance metadata. You can obtain the photo content ID and then create a blockchain transaction to link the metadata and its content ID. And then if you are familiar with the development tool, Git, similar to the updating the source code, 1753 allows you to do the same thing to update the metadata of content by linking multiple metadata to the same content ID, just like Git commits. These commits can happen on the same blockchain or different blockchains. As long as they follow 7053, you can use the content ID to query and get the full content history. These are actually a bit more details. In order to make the provenance metadata upgradable, we introduced a concept called asset tree based on 7053, but I'm not going to the details today. If you are interested in it, you can just Google ERC 7053 or use the link here to view it. We also have an open source tool that can help developers create commits on the blockchain and trace the content history. It's called Neat. Since I just introduced the design idea of the 7053, it's coming from the developer toolkit. So I bet you know why our tool is called Neat. And another EIP, which focuses on content consent for AI training, is currently open for feedback. So discussions are also related to how to make it compliant with the IPTC and C2PA standards. So please join our discussion and provide your valuable feedback. So thank you for listening. So and you can find our use cases, the document of numbers protocol, and more material on our website. And nice to meet everyone today. Thank you.
Thank you very much, Bofu. So we'll just go back to my placeholder slide so you can see everyone's names here. So we now have lots of time, 26 minutes for Q&A. So very happy about that. So maybe just going straight back to Bofu, I think one of the sort of obvious questions about something based on blockchain that handles images and image metadata is the scalability question, and whether someone like Getty Images or Associated Press or AFP could put all of the images onto a blockchain. And have you done studies to see how it would scale and what resources and costs were required and how it would work with all the verification work as well? And all of that activity on a blockchain sounds quite complicated and time consuming. So can you reassure us there?
Yeah, sure. So first of all, so in the presentation, so I think the key idea is that we generate the unique ID for every digital asset. So it will be the starting point. You can search or get all the history on Chen. And after that, we can preserve all the update different metadata. But here, there's another key point is we won't put all the raw metadata on Chen. Instead, we also generate the unique ID for the metadata itself and put the ID on Chen. So basically, because the ID itself is very small data, so we are very confident that if we only preserve the content ID on Chen, so we should be able to avoid the congestion over the computation issues on Chen.
And sorry, I missed the content ID part. I must have been writing down someone else's question. But is that something that can survive minor edits to the content, or is it a direct hash of the pixels?
Yeah, so I think the content ID you can think is like powerful hash. So it cannot only using the content ID to check the integrity, but you can also get the content by using the content ID. So if you have the content ID, then you can get the content from the decentralized storage. So if you do any editing of a content, then the ID will be changed. So for example, if we have the original asset, then we generate the original ID. And after that, we create a C2PA or IPTC injected version. So we will have two different IDs, but we will link, we will call the second one like the child asset, and the first one will be the parent asset. And we can create an on-chain record to link the child asset is coming from the parent asset so that we can link all the modified version of the content.
I had a follow-up question to that, but Neal has raised his hand, so I think he might want to ask the same question.
It's kind of related. So Bofu, you mentioned that you can link child to parent. What happens if two different people register the same content? How can you tell which one is authoritative or which one should be the parent if there's no linking between them.
Yeah, so I think that's also the challenge the IPTC and C2PA trying to resolve is because in the future the feature we foresee is that the tools, the content generated tools, they will inject the local provenance first, and then we can register the provenance, local provenance injected content, register on-chain provenance afterwards, so that if someone he got the C2PA injected version and modify it and do the on-chain registration again, we should be able to check from the timestamp, then we can see the original one, it should be registered prior the second one. But for example, if there's some extreme conditions like for some reasons, the registration time is different, but because all the records on chain is transparent, so that we will have an open and transparent environment to discuss and innovate.
Great, thank you. So maybe moving on to ask a question of Neal. So Jeff, who we'll be hearing from later, asked a question about the exploit, the editing of the date. So that exploit seemed surprisingly simple and quick. Are there other known or possible exploits?
There are many other exploits. I've been actually writing about them on my blog. This particular one actually isn't a bug in the C2PA code. I traced down, because it's open source code, I traced down the vulnerability. It actually comes from the OpenSSL library, and the OpenSSL people say it's not a bug, it's in the standard. So there are actually many other vulnerabilities, assuming that Leonard's team can get around this. This was a 1-minute demo. I can easily do a 3-minute demo that is a little more sophisticated and again, gets around modification, and you can alter things. So the simple answer is yes, there are many other exploits out there.
Okay. Leonard has his hand raised, so I think he wants to say something in addition to that.
Yeah, I think one of the things that, and you know, I well aware of Neal and his work, and certainly am not challenging it in any way. But the one thing I do want to point out to folks is you have to consider with any standard, whether it's IPTC or C2PA or PDF, or pick your favorite standard, there is the definition of that standard, there's the specification itself, and then there are implementations of that standard. And so sometimes those get intermixed when we talk about vulnerabilities and exploits and things of that nature. And so, you know, we want to be careful when we talk about an exploit against a standard versus an exploit against an implementation of that standard. And again, that's not to say that C2PA is perfect. Yeah. We know it's not. We actually document a lot of known problems, and we have since day one. But I just want to be very clear that it's important to talk about the differences.
In this particular exploit, it's in both OpenSSL and GNU TLS.
It's going to be a fun thing to work through. So another question that came up for Leonard while we've got you there is, can you clarify the patent situation around the technologies used in the C2PA spec? So will C2PA technology always be free to implement and to use from a patent licensing point of view?
Great question. I'll give you the short answer first and then explain it a little bit. So the short answer is that there are no patents that have been declared against C2PA technology, but even if there had, our patent policy, which is consistent with W3C and other well-known patent policies, is absolutely that we want it to be freely available and without charge. And one of the ways that we went about doing that was we've had a design goal since day one to always use pre-existing technologies on pre-existing open standards rather than trying to create new things from scratch. One of the reasons being that this way we don't potentially introduce any opportunities for patents. That's never been our goal at all, was to patent any of this technology. We want it to be free.
And maybe there was a question about Adobe's relationship with all of this and the fact that many of the C2PA content authenticity people are Adobe employees. I don't think that's a secret, but is there anything particular you want to say about that?
Yeah, sure. First off, actually, I think that, as I mentioned, there are over 100 members of the C2PA. On any given one of our working group calls, the number of Adobe employees is small compared to those from the myriad of other companies who participate. That said, look, Adobe does pay my salary, and I do chair and have chaired the work since the beginning. But I also try to be very clear when I go and I speak to anyone, even individually or in groups like this, that I do so representing the C2PA without representing Adobe's interest, unless there's a specific question asked about Adobe. So we are not by any stretch, and we are not the largest by any stretch company that is a member of C2PA or participates. There are others that certainly participate with greater numbers than we do.
Great, thanks for clearing that up. Maybe a question for Dennis on this. So as an implementer working with all of this, how do you find the pace of change around the C2PA technologies and the fact that new versions of the spec are coming out every couple of months and the tools are being updated very often? Is that just par for the course these days, or is it something you've struggled to work with, or that you find could be better in some way?
Well, certainly it's been a challenge. This is some pretty tricky technology, and so it took us a while to get some of this technology to work, and for the longest time, for example, I didn't even know what an ingredient was. So finally, one day it dawned on me, oh, I'm supposed to use an ingredient. So there it is in the spec the whole time, but you don't know. It's hard to interpret that spec. And then we've also recently discovered some issues, such as a lot of these cameras that when they sign the picture, they don't put a timestamp because they're not connected to the internet. And so when these photos are taken and they're signed in the camera, they will expire at some point, because if you don't have a timestamp when that signing certificate expires, so does the certificate of the photo. So we've had to develop techniques to do things like what we call stapling, where we will recognize that a photo doesn't have a timestamp. So we'll go ahead and sign it again to make sure that that signature that came from the camera that doesn't have a timestamp, by signing it again with the timestamp, we can actually preserve that original signature. So we just keep on discovering new little tweaks, and I'm curious to see how things work out with this trust list, because that's a big problem people have had using the technology, is just getting the certificates taken care of. So I'm curious to see how that works out. That's a big, a lot of questions still going on right now. So, but we're slogging through it. So.
Yeah, for a while in the early days, it was possible just to create any certificate using OpenSSL and sign content, and the verified tool would say it's valid. But that changed a long time ago. And I think, in a way, sort of taking my moderator hat off and putting my IPTC Media Provenance hat on for a second, we are quite happy to be only attempting to solve a very, very small part of the provenance problem, which is this content was, like, the content that you're looking at is the content that was published by XYZ publisher. So we don't have to say anything about this is true, about the fact that the metadata is one thing or another, the fact that the pixels are one thing or another. What it's saying is the same as if you go to the BBC website now and have a look at some content. If you're seeing that content out of context, then you have some way of checking whether it really is the content that was published by the BBC or by whoever the media organization is. And it's basically a different problem than the overall glass to glass problem that's being solved by C2PA at the macro level, which is definitely a valid problem, and it's a really tough one. And I applaud Leonard and co for taking that entire problem on. But we're almost selfishly saying, well, we're going to just focus on our little part of the problem and make sure that works for media organizations, and hopefully that will be something that's a bit simpler to move on with, and then later on we can start to look at the glass to glass throughout the entire workflow problem using tools such as Krawetz and Photoshop and all of the cameras that are coming out with C2PA embedded as well. But there's plenty of time to solve those problems. So other questions? Leonard's raised your hand.
Yeah, there's actually a great question in the chat pod from Sheldon. If you don't mind, I'd love to answer it because I think it's probably interesting to most people. So yeah, so Sheldon asks, he says the trust list idea that we've been talking about seems to be heavily or entirely organizationally based. Is there any thought to extend this to individual and independent content creators? Excellent question, Sheldon. So the idea here is that what we actually want to do, let me back up a little bit. Human to human trust is a very difficult problem. People have been working on that problem for over 25 years. I was working on it back in the 1990s, and it's not a well-solved problem. The closest thing we have to it are what are called social graphs. Basically, you think about your friends list on Facebook or Instagram or LinkedIn or whatever your favorite social network is. And even then, you wouldn't necessarily say that you trust all of your friends on Facebook, for example. But so what we want to do instead, at least at the C2PA, is we've been working with the identity standards community, and there's a number of them. One of the most well-known ones is a group called Trust Over IP, and they partner with the verifiable credentials community. So what we want to do is actually connect your human identity with the tooling that you use. And so that downstream, what we want somebody to see is that Sheldon has delivered this photograph using Photoshop, and that it's well known that Sheldon uses Photoshop to do his image editing. And that pairing of tooling and verifiable identity is then what will enable that trust downstream. So absolutely, this is something that we as an industry, not just C2PA, but the entire computer and technology industry is attempting to address. And within C2PA, we're trying to work with where that industry is leading us.
So, Leonard, I have a question. With regards to this trust list, who can get added to it? How is it vetted? And how do you address the personal bias? Like, we don't like Neal, so we're not going to vet him.
Well, I like Neal, but I totally understand the concern. It's also another great question. So we're at the C2PA, we are currently defining all of the answers to those questions. So I don't have answers right now. What we are doing is defining the answers to all of those questions, and we will publish a public document that describes the answers. But I can give you some very big brush strokes, if you will. So our idea is that what we want to do is to validate implementations, not organizations or identities. So if someone comes to us with an implementation, it will be run through a publicly documented and well understood process to ensure that the software or hardware meets the qualifications. And you can think about this like getting the Bluetooth logo or the 4G logo on a device. It has to get that logo, you had to have gone through a process. We are setting up a similar type of process, and that instead of getting that logo, like you do, for example, with Bluetooth, that will get you a certificate that is on the trust list. And so becoming part of the trust list is not about who you are or where you are located or anything like that. It's about the fact that you have built an implementation that establishes, that meets the qualifications. And so it removed a lot of those concerns.
So an attacker can easily create a solution as long as it matches those minimal requirements and be on the trusted list.
As long as they're willing to, as long as there's implementation matches and they're willing to agree to all of the legal contracts that go along with it and the responsibilities that they will have to hold by. Yeah, absolutely.
Oh, the
On
legal
the
stuff.
media
I'm not worried
side, we're
about.
looking at similar things in the Project Origin Media Provenance world, where we don't want to focus on who the organization is and like whether they deserve to get a certificate or not. It's more just about saying this is an identifiable organization and this is the content that they've published. So we're not talking about whether it's right or left wing, whether it's just totally made up or not. We don't concern ourselves with that. It's just purely about the identity of the organization and linking the content with that organizational identity. So it's the same problem from a different point of view. There was also another question from Ned to Leonard might be able to answer this, or possibly James, and then Dennis from the photo mechanics side of things. When are we going to see fields that say, don't use my photos for AI training in both Adobe and Photoshop and in Photo Mechanic and Photo Mechanic Plus? It's come to my attention that at least one company, not Adobe, has used my wildlife photos for AI generative learning. So that's asked by an on-the-ground photographer who wants to be able to put these fields that we've defined into their content.
I can talk about that in 10 minutes from my
That's what I
Okay,
was
great.
hoping James was going to cover that. Great.
And Dennis, from your point of view?
Yeah, actually, we in our preferences for the authenticity, we do have an option in there that says "Do not train," so you can set that. And also, we put in there the ability to declare your digital source type in the CTPA manifest, not just in the IPTC metadata. But yeah, definitely, it's an important thing. I'm fully for. All my pictures are going to say "Do not train." That's for sure. So that's basically an option. Some people may want to allow it, but it certainly should be an option for the user to say, "Just don't use my pictures for training." Thank you very much.
Hey, Brendan, we've found a flaw in the system here. One of the presenters was wanting to ask a question, but there's no way if you're a presenter to write into the Q&A. So Jeff Nova was asking, for Leonard, is the C2PA looking into using blockchain as numbers protocol does?
Actually, the way that numbers works, and I'll certainly let Bofu talk more about it, is exactly the way that C2PA sees blockchain, which is that it is a companion technology. C2PA itself is agnostic to cloud or blockchain or anything else. It absolutely can be used in the cloud. There are a number, or blockchain. Numbers protocol is a great example of pairing C2PA with blockchain. There are others. There are examples out there, Adobe being one of them, of pairing C2PA with cloud storage. We are by design agnostic to those things, and we hope that partners and members like Numbers continue to build on top of our work.
Yeah. And I think I can share some our observation and talk with some people how when you should just use the IPTC and C2PA, and what's the scenario you might want to have the blockchain on-chain records further. So for example, in the coming future, we can foresee that because the generative AI is become more and more popular. So more and more the marketing content, they might come from the generative AI technology. So as the user, when you see this type of the content, you might want to know is, are you interacting with the content from AI or not? But actually, you might not care about the provenance much. But if you are interacting with the more higher credibility content, like the artwork or the news media content, in this case, because the content quality will become higher, so you might care about the provenance, like who really the creator behind the asset, or what's the scenario the content is generated. The history and the story behind the content means more for you, so you will be interested in know more about the provenance. In this case, then if you can have on-chain provenance, then it might have more meaning for you, I think.
Great. Okay. Any final thoughts? Maybe we should, it's not a short question, I think, but Margaret had a question for Dennis. Suppose you edit metadata it is stored in a locker, passed to a second credential, but then you have more edits of that same image. Do you have to keep creating more lockers and getting more manifests? Is that a question you can answer now, or is that a longer
Yeah,
thing?
so real quickly, basically, essentially, you put the provenance locker protects the metadata so it can be edited over and over and over and over again without having to re-sign it. But eventually, you need to pass that photo on to another application such as Photoshop. So at that point, you turn around and you sign it. And then if you pass that photo to somebody else and they want to continue to add more metadata, then they can essentially create a new provenance locker and then sign it. So the goal of the provenance locker is to try and prevent signing every time you make one little change. Because normally the photo mechanic, you can make 20 metadata edits in a couple of seconds. And so you can't afford to go signing it every time you make one little tweak. So that's the goal of the provenance locker, is to delay that signing. But if you pass it off to somebody else or some other application, at that point, you want to sign the picture and make it a C2PA photo, and then they can proceed to do whatever they want to do with it. So I hope that answers the question.
Great. So another high-level question that maybe Leonard would be good to answer this, because you've probably had questions along these lines quite often. If there are such a thing as trust lists, and the objective is to represent true authenticity, but at the same time, all of these methods can be misused, then what value does using a stamp on an image have?
I'm glad you picked that one. I was just going to ask to answer that one. I think that's a great question, Margaret. The way I actually talk about this is very simple. Trust is not something a machine can determine. Trust can only be determined by a human. And Sheldon's been asking similar questions in Q&A as well, which is that at the end of the day, it's up to the human that is consuming a given asset to determine whether or not they trust it. And each human is going to use a different set, though everyone will be given the same set of what we call trust signals, but each human will evaluate those signals very differently. Some people will favor organizational trust over individual trust, some the other way around. Some will prefer one human or organization over another one. Some won't trust anything from country X, or only prefers to read news from country Y, or pictures taken in country Z. So at the end of the day, trust is not a binary value, and it's not a machine determinable thing. Our goal is C2PA, and I would argue the goal of provenance in general, even provenance for physical assets, like when you get a picture from Sotheby's at an auction, for example, you buy a piece of art, you get the provenance, you get the history of it. And it's up to you as a human to say, yep, I believe that these are the people who own this piece of art. These are the people who took this photograph and edited this photograph in the case of digital material. You as a human have to make that final decision. Our goal is to give you as much information to enable you to make the best decision.
Great. Thank you very much, Leonard. I think that's a good place to end the session. So thank you very much to our panelists, to Leonard, Dennis, Neal, and Bofu.